Hello, 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 and welcome to the Rethink Energy perovskite webinar, looking at perovskites in general, but also commercialization and the prospects for that pretty soon, in basically the next couple of years, or maybe even sooner, if, according to a couple of our panelists. I'm Andries. I'm the solar analyst for Rethink Energy, which is part of Rethink Technology, a British media company. And within Rethink Energy, we look at solar, and I particularly like to look at perovskites, among other things. We also cover batteries and hydrogen as in particular, although we recently put out a report on transmission. So this webinar follows on from my latest report on perovskites, which is quite a few months ago now, but I'll be doing another update this year. And really the main conclusion is that perovskites will take over the whole solar industry eventually. Now, eventually, in my opinion, is not really that far away. It's actually 2040. And that's when it's a complete process. And the big gains in market share already start in 2030. And the first large-scale manufacturing starts in 2026. And we see the first products on the market even before that. So on the panel today are three CEOs of perovskite startups, Scott Wharton of Tandem PV, Scott Graybeal of Calux, and Tom Fontaine of HaloCell. And I guess I'll just let you introduce yourselves one by one. So Mr. Graybeal first, tell us just a brief overview.
No problem. Thank you for having us this morning. So about Calux, our job is to amplify solar. Fundamentally, we think that silicon is played out when you consider just what needs to happen to improve the performance of silicon. We believe that you need to really look at perovskites in order to achieve that next level of performance. We're operating just northeast of Los Angeles, California. We have a 50 megawatt site that we've ramped in January of this year, and adding an additional 50 megawatts to bring us to a total of 100 by the end of this calendar year. We're currently in testing with a variety of customers that many of us would know the names if you pay attention to the silicon industry. So we're excited to be here and to talk about what we've been up to.
And you are a four-terminal tandem, basically building perovskites into the glass, you can correct me if I'm wrong, that's used in making a module. So it's a combination with the silicon. And so the same is true of Scott Wharton of Tandem PV, also in California.
Yes. Yeah, also California, we're in the heart of Silicon Valley, and the company's been around for about 8 years. And as our name suggests, we're focused on building tandems, the combination of perovskites and silicon. And I would say that we're making great progress. Probably, I would say, late stage R&D, entering into commercialization. And I joined the founders about 7 months ago to come in as the CEO and help scale the company up. And I know we'll talk more about what the path is for commercialization. So great to be here.
Thank you for joining us so early in the morning, all three of you, at the same time zone. And then the last is Tom Fontaine, a fellow Australian, currently in Vancouver, though. And I'm glad to have you here, because otherwise it would have been just perovskite tandems. But at least in terms of the number of startups, about half of them worldwide and more in East Asia are single junction. So it's not tandem, it's just the perovskite by itself. Anyway, I'll let you introduce yourself.
Sure. Tom Fontaine, our company is HaloCell Energy. And our focus has been on just a pure perovskite product. We've been involved in third generation solar materials for about 20 years, but we recognized perovskites as the next generation about 8 years ago, around the same time some of these guys did, saying, look, this stuff works. It works really well. It's moving fast. This is where the future is. What the different approach we've taken is we are developing products that are completely silicon free. It's just a pure perovskite product, which changes our focus and our direction. And we can talk about that a bit more on what our thoughts on that are.
Yeah, I'll get each of you to describe your route to market in a moment. But first, I'd like to tell the audience we accept questions. So if you have any questions, just type them into the chat and we will address them towards the end of this webinar. And now I'll go back to Mr. Graybeal to just describe your route to market really in the near term. So what market segments you're looking at, what your products are, what segment, and also to the extent that it's you're willing to share, the sort of wattage, the lifespan, the efficiency, pretty sensitive questions, I'm aware, and also the sort of cell size and module size. What is
Sure.
the minimum for those metrics that you need?
Well, that's a great set of questions. So if I forget any one of the points, please remind me. So to talk a little bit about our route to market. So when you look at the solar market, it's traditionally divided up into three major segments. You look at utilities, sometimes commercial scale, and then residential. So we don't look at it from that point of view because our customers are module manufacturers. And so the founding thesis of the company was to improve the performance of crystalline silicon technology. And we started looking at other material systems and settled on perovskites about 7 years ago. And because of that, we've had a view of how do we improve the performance of other people's products? So how do we make modules more powerful and cost less ultimately? And so that brought us down the path of the architecture that we're producing today. And so we started off like everybody, 1 square centimeter, trying a lot of different techniques and technologies, moving that up to 2-inch by 2-inch. And then about 2.5 years ago, we shifted gears to 8-inch by 8-inch substrates, which really helped us engaging with customers because then it started to really look like a module. This is just an early example I showed for the camera. This is something that we started doing about 2.5 years ago. And so you could put a crystalline silicon cell behind it and you could test it much like it was a mini module. And so that was an important leap forward for us. So today in our production line, and I want to stress that our line today is really supporting our research and development efforts. There's a lot of learning that happens when you're scaling from 2-inch by 2-inch to 8-inch by 8-inch, and a lot of learning that happens when you're going to 1 meter by 2 meter. And that's where we're at today. So we're currently producing super straights of that geometry and sending them to customers. And so we had our first shipments in December, and we'll continue to do so through this year as we're ramping up performance. Now, that question of, and this is where it sort of comes to this interesting intersection. There's a lot of, I would call it noise in the system when we think about what's the durability of perovskites. And I think you have to juxtapose that with what was the durability of silicon when it first hit the market. In the 1970s, silicon had 1-year warranties. Up until the mid-90s, it was 10 years. And it was just after the mid-90s when the industry decided, hey, let's make this a roofing product. Let's try to intersect that market. That you started seeing 20-year warranties and 25-year warranties. And it was very market-driven. So when we look at durability of perovskites, we have to have that lens. And the fact that this technology is only 15 years old, and we've taken lifetimes and durability from seconds, when it really used to take seconds for perovskite to degrade, to now, we're talking close to a decade. And that will be exceeded even further. But when we think about the commercial threshold, what we've targeted our product, V0, which we'll be launching this year, will be a 15% efficient top glass. And that's a semi-transparent device to be sold to module companies. And the durability of that, which we've been very open about, will be between, have a T80, which means 80% of its degradation, between about 12.5 to 13 years. And that is sufficient, more than sufficient, that you have a module that will produce more power over its lifetime, a 25-year lifetime, than if it was crystalline silicon alone. We forget that silicon also degrades. And I think NREL has done a great job doing studies of existing power plants to really prove that. So if you can hit those parameters, that's your minimum threshold for entry. And what customers and investors want to see is, hey, getting this large format product out into the marketplace and going through certification. And so we've got about a dozen customers today that we're working with on various stages of certification. Some we've onboarded just recently. And we're pretty excited about the potential here. And we think that while the products themselves, the modules, which our customers bring to market, won't be out this year, our product will be out this year and selling into that module channel.
All right. Well, I now have the same question for Mr. Wharton. And you're also pursuing the selling to module makers, aren't you?
Maybe. I would say our approach is that we're building a utility scale product. So as Scott said, there are different segments. We're really looking at that segment overall. And part of our strategy is really to build a standard size. So in the utility scale market, it's roughly 2.7 meters. So our strategy is to build something that fits in with the same ecosystem. And I think we've said publicly that we can hit a 26% tandem overall. And I think the goal is to make sure that it's differentiated enough versus the silicon today PERC going to TOPCon, so that customers have a clear choice overall and making sure that it's a lot higher in efficiency and performance versus the current things. I believe that if you're too close to the existing silicon products, then a lot of customers are going to say, why would I take the risk if it's something similar. So I think it's incumbent on all of us to have something that is significantly better than what's out there in the market, not just the same but cheaper. And I would say part of our value prop, and I think it's true probably of my colleagues, is perovskites ultimately is just a better, cheaper solution. I think that's why you and Rethink are positioning perovskites as being the future. But I think there's some also interesting lower total cost of ownership advantages. So if you have something that has a higher power density for the same size, then you save on land, you save on installation, you save on balance of systems costs. And I think one of the things interesting about this industry is that we've been so focused on lowering the cost of solar that I think we're getting to a point now where the cost of the panel is actually not the biggest part in many cases of the solution. If you look in residential, the biggest cost is marketing. It's not even any of those things. In most of the other areas, it's land, labor. And as we know, land and labor are only going one direction. They're getting more expensive, not less around the world. So I think we have to start rethinking how we look at the industry. And part of what we're focused on is lowering the overall cost of ownership and deployment, not just the obsessive cost of, hey, how do we all commoditize ourselves to death and create value in that way. So that's part of what we're doing. And I think that's part of what we're focusing on, a product that's a tandem that has higher efficiency overall, because we think it's going to provide better value overall to people deploying.
And for a long time, I thought that perovskites would go into rooftops specifically first because the space is a bit more limited there, at least in theory, and obviously you're getting more power per square meter. I think you were the one that made me finally realize, at least certainly in America, where the rooftop sector is quite small compared to utility scale, and it's recently suffering, that actually you're going to go into utility scale first. So that was quite an interesting point of view. Although maybe Mr. Graybill's wincing because he's just told me that we shouldn't view it as divided but in that way anymore.
Yeah, I think the perspective that we have, and Scott's correct, and by the way, when we talk about efficiencies for top glass, you remember you have a contribution to silicon, right? So generally you'll take that silicon power, you multiply it by 0.43, 0.45, whatever, something in that range, and then you add the contribution of perovskite. So I think everybody's kind of targeting the same thing, starting out with about 26, going to 27, 28 shortly thereafter. But to that point, most of our customers are actually skewing towards utility as well, because there are tremendous advantages. And I think Scott's absolutely correct. Once we start looking at sub 50 cent a watt installed costs in the US, that's a tremendous lever to just drive acceleration, generally speaking. And I think all of us can speak from the same sheet of music. Hey, we're talking about 30% improvement in power, 20% more kilowatt hours, and 20% lower delivered cost of energy. And that really is derived based upon, look, this technology is relatively low cost, it intersects the right price point, and it also can deliver a tremendous amount of performance that developers and utilities can take advantage of. So it is about that ecosystem play for sure. And when you really combine this, when you're looking at high density installation methodologies, that's where it really becomes quite interesting.
Yeah, I just want to add to that I think that I'm new to the industry and I've less experience than all of you guys here. But when I first came in, I think there was like residential is for perovskites and utility scale is other. But I think what I've found and the feedback I've gotten from the market is not all utility deployments are in the middle of Arizona where there's abundant land. I mean, we're putting solar all around the world. So if you're in, a lot of parts of the world, whether it's an island or you have limited land, or you're in New Jersey, for example, land is quite expensive, and labor is also expensive. So I think the idea that utilities only want cheap things and residential wants, premium because of space, I think that's wrong, and I think that's part of why there's opportunity for perovskites in both. I think it's a misunderstanding in the industry that I've certainly been educated on from the utilities that they go, no, we care a lot about land and labor too.
So the two of you have just described how you can take over like the mainstay of the industry with a product that is literally silicon but better. But there's even more to perovskites than that. And like I said, I have an Excel file with several dozen single junction companies. So Mr. Fontaine, you are their representative here, and I can probably think of half a dozen different applications for single junction perovskite off the top of my head. You, I'm sure, have even more. Now, so just same question. Describe your route to market.
Yeah, it's a I guess a left turn in how we're taking our approach to it. And it was really probably four major decisions that we made about 4 years ago. And that was that, first of all, we need this technology works. It works now and it's ready for commercialization. So let's get it out of the lab and let's focus on nothing but commercial, how can this thing be commercialized? The second thing that we said is, look, probably where the best market is in the short term is in low light applications, because perovskites work particularly well in low light, and then we're not directly up against silicon, because we see companies that are trying to use silicon panels to charge batteries in low light. They don't work very well. You only get 3 or 4% efficiency indoors for a little silicon panel. And the third thing was, to do this properly, it should be roll-to-roll production. We take advantage of all the aqueous solution properties of perovskites, and you can see that each layer can be laid down using a roll-to-roll process. So that lets you get very high volume, uniform products at low cost. And then the last part of that was we wanted to be silicon free. I mean, we don't like the silicon is part of the problem, in the sense that there is some dependence on silicon. You made a really good point earlier that we haven't really seen that, and costs are coming down. So I'm not saying there's anything wrong with the model. We just said, look, in the first iteration of our product, we're going to go make sure that it's silicon free, and we're not competing directly against large companies that are already in the silicon business that might be able to also start putting perovskites together with their silicon. So we're not competing against them directly. That was our point of view.
And the thing with silicon is they may now have built a huge amount of overcapacity, and there's just like enough for 1,000, maybe 2,000 gigawatts. I gave up tracking all the capacity that they built, but it's all in China. So it's not really a supply problem or a price problem at all anymore, quite the reverse. But there is this geopolitical question very much. Anyway, so carry on. And what are the various products? You've already mentioned indoors, and I think you told me that the perovskite indoor efficiency is 20%, but you can take it to 30%. That's the same thing I heard from Polish Sala Technologies. So, but there's much more to it, isn't it? There's many different products that you could look into next.
Yeah, I mean, you talk about worry about OPEC as a control the oil business. The silicon wafer business is much more tightly controlled. We haven't anyway. That's back. So back onto the. So what we found is there's really 4 products that we're addressing with this low light application. One is small electronics and IoT devices. So that's like things like the remote controls. We have been working with a large company that is trying to replace batteries or charge batteries with remote controls. And they're saying the life cycle of one of their products that keeps 100 million small batteries out of landfill. And we've sent them samples, they've tested it, and they said, this works great. We really like how well this works. And then there's IoT devices. In particular, we've been doing work with a couple of electric shelf label companies. Again, it's a perfect application. There's space, there's low light, it's low power low power usage for these shelf labels. And they were saying about 30% of their customers are saying, do you have a batteryless solution? So now they're saying, yes, I think we can provide that. So we're working with them. And then third, there's an area of printed electronics. So there's some really interesting things being done in the printed electronics space. And because we're already designing our materials in our product so it can be printed, these devices need power. So we've been talking to some of these companies saying, why don't we print our power supply with your electronics, and then it's all, and then encapsulate the whole thing. And so that may be there's a couple of companies we're talking to, and I'll be going to a conference next week on that topic, just to see, what are the opportunities in that space, because it seems to make a lot of sense, at least at this stage. And then two other niche products is that we're focused on because they're much higher volume, but much lower cost, is space applications and also drone applications. We're working with a company that has tested our materials, done the calculations, and they said, look, because of the lightweight of the product, because you can get low light and full sun benefits, so you can even have panels underneath the wing. They said they can get, and also by incorporating a lighter battery, they can get about 6 times the life span in the air, 6 times the flight time for their drones. So that's a meaningful improvement. So those are the markets that we're going after.
Shall we talk about satellites or not?
Well, that's the space. That's the.
Oh,
space.
yes, you did. So,
Yeah,
but I have a question about it, which is I just want to remind myself of the numbers. Was it $50 million for one of these small satellites? And a very large fraction of that is actually the gallium arsenide current photovoltaics that's used on them. And so surprisingly, the cost of the solar can actually be cut significantly as a fraction of total satellite cost.
That's what got their attention and our attention, is that, well, gallium has become a secure mineral.
Oh, yes. It's yet another victim of this trade conflict with China.
And so the costs were already, let's say, 100 to up to 1,000 times more per square foot for gallium arsenide products. And it became a significant part of, we're talking mostly about nanosats. So it's the small or CubeSats. So, it's not, we're not talking rockets, but they still need power. And the products that they were using were a big part of the component of the cost of the devices. And as we're launching more and more of them for navigation and communication, we talked to a Canadian company that plans to launch 1,600 devices in the next couple of years. So it's really interesting, because you don't have to worry about things like humidity or oxygen. So it's a slightly different design, but you do have to worry about other things like slightly higher temperatures and colder
a few hundred degrees, was it?
And radiation. And so it's a specialty application, and we don't see it as, it's not going to be it's not a huge business, but it will also be very, very good to say, these products are so great, we put them in space.
And beyond that, yeah. Meanwhile, you're dodging the humidity and the oxygen.
Yeah, so it's good enough for your TV remote. If it's good enough for this satellite, it should be good enough for your TV remote. So, I mean, there'll be some money to be made in it, but it's not the large volume.
And we don't have any of the several dozen Chinese single junction companies. But from what I know, as panelists here, but from what I see, they seem very interested in the building applied and building integrated segment. So it seems like they might force through a real revolution in that sort of rooftop. Well, it's not rooftop anymore, but it's distributed residential. Anyway, I will now move the discussion forward onto really the general solar market and how perovskites interact with that. Because in a way, it's not actually a great situation right now for anyone who's not Chinese and who hasn't just halved the cost of solar modules, not the full project. Now, that's just unpleasant, really, if you're trying to introduce your own product. But there is a silver lining. There's two, really. The first is that I don't think silicon can get cheaper than this. At least, well, it can, but it requires future technology, future progress. And so it will, if it declines from this point, it will be very, very gradual decline. And Mr. Wharton always tells me, no, they're dumping, they're selling below the cost of production. It's going to increase, which it's definitely not going to decrease anywhere fast. I think this week it decreased by 0.01% or something, and they have, we've already seen the worst that the Chinese can do to us, so to speak. They've already created a sort of 2 times factor of overcapacity, and there's already stockpiles all over the place. I mean, this bizarre sort of 80 gigawatt stockpile of modules sitting in Europe apparently, and significant stockpiles in Brazil as well. Maybe not a big enough one in the US, though, which is an interesting point. Now, anyway, I'm talking too much. I should be asking you things. So I think the question is, like, with Western manufacturing, Western reshoring efforts, specifically kind of running up to a bit of a brick wall on the wafer segment with cubic PV's recent cancellation. And in general, that was always going to be the hardest segment, and the Chinese have 98% of it. And polysilicon, we have old polysilicon, but new polysilicon is a bit of a daunting prospect because, like wafers, it's so energy intensive. So really what we have is a bunch of modules and cells, which U2 tandem companies want to work with anyway. And you've also got the IRA subsidies. They might not be enough for fully verticalized silicon, but you're claiming not just the cell, but even the wafer subsidy, if I remember correctly. So you are, and another thing, and again, I'm rambling too much, but I recently there was this Australian solar roadmap published, which was, it restricted itself from looking at perovskites because it didn't want to do too many speculations at once, I suppose. But the conclusion they came to is that Australia can't pick a trade war with China, so it would have to subsidize even more than the US to have its own solar manufacturing. And it's just like, well, this leaves perovskites as the only solution. And Europe's silicon is just dying, basically. So would you say you're in a very strong position to just take over Western manufacturing, perhaps even Indian manufacturing as well?
I think that there's an important thing we should acknowledge. If you look at the manufacturing cost of a perovskite cell, compare that to a crystalline cell, even against a tier 1 Chinese producer, we're cheaper. And, though we hate to talk about, hey, cost down, but that's a reality of our market. We sell a fundamental commodity, and that's an electron. And so we have to be very conscientious about how that comes together. So if you do an apples to apples comparison, Asian manufacturing of perovskites compared to tier 1 Chinese silicon, perovskites are lower cost. If you compare Southeast Asia production of a silicon cell to US produced, and I'm talking about Los Angeles, which is not a cheap area, we're cheaper. So that is starting now. And if you apply Wright's law to this whole thing, what's driven the silicon industry is just Wright's law. It's the fact that, hey, you double cumulative output, you see a 15% reduction in cost. And that's something that we've observed, and that's really the learning rate for this industry. It's similar for perovskites, and we're at the very, very early stages. Nobody really has shipped more than, let's say, 20 megawatts globally of perovskites. There's some players in China I think have done a really good job in getting the product out early. We look at those as existence proofs. When people say, hey, is this possible? We say, yeah, it's possible because so-and-so did it over in China and they put out a couple megawatts of pilot projects. So with all that being said, I think I agree and disagree with your supposition that it can't get lower, because what we see today is much in the way of just trying to control a market, right? There's a big thrust right now for the super majors in solar to push out the smaller competition and really refine the industry. And so I think we will see a bit of a price rebound. It smacks of 2016. I remember selling modules into a project in North Carolina at 68 cents a watt. And by the end of that year, we were selling at 25 cents a watt. So it was catching a falling knife. But I think the lesson that we can extract from this, if you're going to catch a falling knife, catch it by the handle and not the blade. So we have to be smart about how we position our products in that context. And I think all of the models and all of the analysis we've done with customers has showed still including a perovskite and getting rid of this low efficiency and mid efficiency market. That's really the game here. And we start talking about modules that are coming out with a minimum efficiency of 25% with a very clear line of sight to 30% in the next couple of years. That's a game changer. And, that's part of the ingredient. Now, when you think about how perovskites evolve over time, ultimately, I think we will be looking at perovskite-only solutions, but I think we need to find an on-ramp for the technology, and that on-ramp, from our perspective, is this 4-terminal hybrid tandem approach, get it out in the market, stand on the shoulders of giants, and naturally, the technology is going to evolve with a lot of hard work, right? But we'll get there, where perovskites will have a durability that matches, if not exceeds, what we see with silicon, with performance that's just off the charts, and we're on that trajectory.
Anything to add from Mr. Wharton or Mr. Fontaine?
Yeah, no, I like what you said about that silicon free is the ultimate goal. I
do think that eventually you'll have perovskite on perovskite tandems, but I think it might take a while because silicon is such a well-established product. It's whammed itself up to 30-year lifespans and 25% cell efficiency. But anyway, sorry to interrupt. Carry on.
No, we're taking a different approach. We're saying by producing roll to roll, we'll be able to produce a full sun and a low light of perovskite cells, and then put them together. So we'll have a perovskite, but it'll be unflexible. And Is that?
I think we're getting some echo from someone.
Yeah.
Anyway,
so I totally am with you. That silicon free is the ultimate goal. We're having a different path to get there. So we'll start with low sun, low light, and again, that's about acceptance into the market. And because any new product, if you think the first solar cells I saw were the little cells on calculators.
Right.
And that was, as far as I know, that's where solar cells started getting accepted. They went, oh, this is cool. You can power your calculator with it. And so we're following more that path. But it also, I can see the logic behind your strategy. We're just taking a slightly different road to the same ending.
And so it's really a road that only you can take, because all of the other thin film technologies like cadmium telluride and gallium arsenide, they're like silicon in a way, perhaps not to the same extent as silicon. They've sort of spent a few decades reaching their current strength, and they're not going to advance as swiftly as perovskite. So all of these things like satellites, like integrated building, applied photovoltaics, and also EV roofs, that's kind of all yours to take, as well as considering the fact that those segments in themselves are going to grow much bigger. Because I think a big thing, certainly in the US, perhaps worldwide, and even in China, where they're no strangers to building transmission lines, is I think there will be a constant shift towards demand response, towards distributed eventually, perhaps not even this decade, but it will certainly kick in a big way in future. And that's, the single junction thin film stuff that you can just paste anywhere is really the thing that can take advantage of that. Even though I think, you can download my perovskite reports if you want to look at when I think it will happen. I don't quite remember off the top of my head, but it's somewhere, that really starts kicking in more than a decade away. But it ends up being very, very important. Anyway, you mentioned roll-to-roll. Sorry, go ahead.
I'm sorry.
Yeah, Mr. Wharton.
I was just going to add to what you said. There are a few fundamental questions. One is the technology for perovskites fundamentally better in the future? And I think we're all saying yes. I think your report says yes. The fundamental cost and structure of making these things is lower. So that's one answer to the question. I think the second one is kind of a classic. Will startups win against big companies? And of course, this is my fifth scale up in a row. I've done a whole bunch of startups. So I've seen this movie before where it's always, the big companies will always win because they have all these advantages. And we all know from our experience that's sometimes true, but a lot of times that's not true. And why? Because usually larger companies get stuck on their own technology curve, their culture. They don't want to disrupt their own. They don't want to disrupt their own business. So, can the big Chinese companies win? Yeah, of course they can win. Will they win? History still hasn't been written yet, but I think the world has a lot of history of showing that startups, when you have a disruptive technology, not an incremental one, can stay ahead. Now, obviously, that'll be incumbent on the players here and others to innovate. But I think that's one of the things that Western and California companies are pretty good at, is innovating and running fast. At least that's what I'm betting on it. And then the third thing ultimately is there a level playing field? So I would say, of course, if the Chinese companies are allowed to play unfairly and dump and sell below cost as they are now, it's very hard to compete with that. Fortunately, I think you see, at least in the US, there's an acknowledgement that just like Europe tried the experiment of buying all their energy from Russia and that didn't work out so well, we've made a decision as a society. We can't buy all of our future energy source from one country, any country. And you see Europe and Australia and other regions, India, looking to make some similar decisions. Maybe or maybe they'll all do it. So I think it's really a combination of those three that are on our side. And then, I always tell our investors and team, it's all about execution. These are all nice words. We have to deliver, and we'll see who delivers. But I have no doubt that perovskites will win. That's what I tell people. It's just a matter of now. Fun question is who will do it?
I really like what Scott had said there, because I think one thing that we learned from the last time we've gone through this, so this was really starting in the 2010s, and we saw it get another inflection point in 2015, 2016 in the industry, was that we didn't take it seriously. When China was really beginning to gain a lot of momentum, and we thought, that can't be true. That can't be what they're selling for. And sure enough, it was. And I think we're a lot smarter this time. We've taken those lessons learned. And just a case in point, how do you deal with low-cost labor? Well, you can deliver automation. How do you deal with access to a significant amount of low-cost capital? Well, you find your own pathways and leverage things such as non-recourse project financing for expansions, et cetera. So we've got a deeper toolbox now, taking those lessons learned into consideration as an industry than I think we did 10 years ago. And I think we're a lot more, we're paying attention, let's just put it that way, to what's happening and making sure that our initiatives and our strategies can still win out and given that ecosystem.
So I think I'd like to shift the discussion onto manufacturing now. And that would be that really just looking at the two costs, investment cost of the facility and marginal cost of production. I think I'll start with marginal cost of production. So silicon, a lot of this is electricity, and a lot of that is just coal power in China, basically, in the Siemens process, which is something like 1100 degrees Celsius, and then the Czukowski process at 1400 degrees Celsius, and goodness knows whatever else when they make those quartz crucibles and all the rest of it as well. So how much less energy and how much just the energy, how much less energy do you use? This is for all three of you, to make your perovskites compared to silicon per kilowatt.
So it's 20x.
Well,
20x cheaper.
20x cheaper.
In energy?
Standpoint.
Sorry, in energy or dollars?
Energy. So
dollars.
Here's the number. It's 120 kilowatt hours to make a square meter of silicon solar cells, and it's 6 kilowatt hours to make a square meter of perovskite solar cells.
I like his answer better than the one I was going to give. Our founders did a study and a paper, which I guess we can publish with Columbia University. I think it's out there, looking at the power. And I think it's about 1/10 when you compare like wafer to wafer. When you look at the overall module and everything, it's a little more equalized. It's about 20%. And even a tandem, even incorporating the silicon, is about half. So it's anywhere between 1/10 to half overall on the overall. But I think Scott's right on the core perovskite to the core silicon. It's way, way cheaper, whether it's 1/10 or 1/20th. I think all of us would agree, and everyone listening, that is an order of magnitude better than what you get. And if energy is one of the main inputs, which it is, then I think that's part of what's driving the cost advantage, in addition to just being a simpler manufacturing process.
And we can tell Columbia, I just looked at our electricity bill. That's how I got my numbers.
I hope you're right.
But of course, your numbers don't include things like glass that you still end up using in the end.
Yeah, absolutely. Everybody uses glass, so that's apples to apples,
and
right?
I think there's a fair amount of electricity in melting that, probably.
That may be the difference, because we're even looking at so even with the glass and all the other things around it, perovskites have a substantial advantage on manufacturing and energy. And it's also, for people listening, when they're thinking about net energy costs and net zero, you not only need to think about the electricity source, but what does it take to make it? So I think as people are looking at their the type 3 or level 3 emissions, perovskites are going to win over silicon panels as you get scale.
Completely agree. And I mean, that was a big driver for us to say that we wanted to make sure silicon wasn't in our products, because if you have a obviously silicon tandem, you still have the silicon, so you still have that in your total product. Which then that also then cut us out of the markets, the bigger markets to start with. But that was that was a strategic decision we made. But it was because of all the things you've been saying about silicon. But we found on our side though is because with the roll-to-roll production and we've got up to we think we can get about 30% efficiency in low light, and we've got up to 40% in lab conditions. But we're taking this out of the lab, so we can get close to 30%. And we're finding that the market for this product is even far bigger than we thought, because we're not competing against silicon. So it's put us in, we feel, in a really, really interesting and potentially lucrative situation. So we're competing against batteries, which are already toxic, and this stuff's recyclable. So we can take our thin film product, and it is recyclable, easily recyclable.
I have a question about the roll-to-roll. So why is roll-to-roll so often mentioned in conjunction with single junction?
Well, you need the flexible substrate. You can't just So it doesn't have to be single junction. It can be if you take two lines. Let's say ultimately we see we'll do perovskite tandems. That would be quadruple junction, but there'll be a low light and a full sun product that they'll either be done in a series or be done in parallel and then glued together at the end. But
and if I recall correctly, the max temperature you're looking at with that is, I think in all three cases, is something like between 150 degrees to 300 degrees Celsius, just as a comparison to the earlier temperatures I mentioned for silicon.
I think your answer to the question is actually the opposite. Why are other applications not using roll-to-roll? And I think the simple answer is, I think in most cases, glass is just a known quantity for having great reliability outside in the elements. So I think part of our strategy, and I think it's the same for Calyx and others, we want to leverage all the great R&D and work that's already been done in the solar industry. And a lot of that is glass and encapsulants, which I think some of the questions like, how do you get the reliability? And I think the answer is don't reinvent the wheel. Leverage all the stuff that the rest of the industry has already done. And I think all of us as startups, we have to pick our poison. Like, what are the problems that you're actually going to solve? And I would say part of why we're doing utility scale and tandems is there's so many other questions, whether it's silicon or encapsulants or glass or all of these things already solve problems. Why would we reinvent them? And so I think that's the answer to many of these questions that are coming up is do whatever the current people in the industry are doing and innovate on the part that matters by creating a better performance.
Yeah, pick your battles, right? It's hard to do both, right? But look, some people are doing a great job at it, I'm sure. But yeah, to Scott's point, I mean, working with float glass or heat strengthened glass, it's well characterized. Architectural glass industry has been doing it for, 50, 60 years, the types of coatings that we're talking about. So yeah, it's, get really good at perovskites is kind of our philosophy as well.
Yeah, and I just add to that, I think there's an opportunity in the future to lower, like I would say for perovskites, one of the interesting, I think Scott will agree, I think probably the biggest cost of our products is glass. So is there an opportunity to get it even cheaper using roll-to-roll or plastics or other things?
100%.
Absolutely. Do we need to do that tomorrow to get these products out? I would say no, we want to get these products out. They already have an advantage, but do we have the opportunity to make them radically cheaper? Absolutely. And I think those are methods that I'm sure all of us will explore in the future to kind of get the cost down.
So I think someone once told me that the investment cost for one of your 4-terminal, I think it was, type of facilities is sort of similar to First Solar, a similar amount of, and similar in terms of the machinery as well. Is that accurate, or would your investment cost be lower?
It should be lower. And the reason being is that I think there's a push in the perovskite industry in general to try to minimize the amount of vacuum process equipment that's in there. If you're doing a solution processing approach or meniscus assisted coating like we're doing, that's an important feature. That's one of the things we look as being as an incredibly important part of our cost down approach is to how do we mitigate the amount of vacuum process equipment that's needed and just solely rely on environmental controls and as much as we can at atmospheric pressure processing. So I think, I don't know their line in detail, but I think that the technique that's used leverages vacuum process technology for deposition of the absorber. And so, we issue from that. So we prefer to look at other methodologies which we can deposit the absorber. And so we should be lower cost from that standpoint. But in general, if we were to compare, let's say, a soup to nuts heterojunction line in US prices, that would be somewhere around $105 and $110 million for a gigawatt. And that's just the CapEx. You're looking for something for perovskites, it should be closer to $50 million.
So the next topic I was going to get into was the R&D challenges, which is degradation, large-scale deposition. We're sort of already getting into this topic. So where's the lifespan, efficiency, that sort of thing, size going to be in a few years? But I suspect that I probably shouldn't be the one asking those questions because I've just noticed we've got a very large number of questions from the audience. And I'm sure that quite a few of those are going to be based on around that sort of thing. We've got one from Christian Linker. I'll just go through them as they come, so to speak. And he's saying, what kind of disadvantages and advantages do you see when using vacuum-based processes for manufacturing? Will evaporation or sputtering become the standard for high-quality perovskite cells?
No.
No.
No, I think it just is the opposite of what I was just mentioning, right? So I think
Yeah.
vacuum process technology really needs to kind of take a back seat. And if we think about what we leverage our vacuum processes today for, it's for commodity films. So it's for TCO depositions. And look, it's a bit of a capital equipment burden to have to use process equipment of that nature, because you need to have highly trained people that can run vacuum process equipment. You need to have a supply chain that's in place that can support the maintenance requirements for that. Fortunately, there's a lot of suppliers out there, which is great. We see the atrophying of the flat panel display industry as providing an opportunity for different vendors and new vendors to come to the forefront, which is something we've been able to take advantage of with our Asia presence. So with that said, we'd like to see less vacuum process equipment in the stack versus more. And I don't think it's a necessary requirement for high quality films.
Yeah, we've come to the same conclusion, and that's why we designed. That's the way we've been working as well. All our processes are designed to be in a normal, clean, low humidity electronics quality lab, but not vacuum vacuum processes.
So next up, we've got 6 questions from David Martineau, and the first one is, how do you address lead acceptance / regulation / mitigation?
Well, our products, I think many of the others for perovskites use lead, but we use an incredibly small amount of lead. I think the statistics are 1/15 of the current solar panels. So yes, there's lead, but it's way, way, way better than the current solar panels. And I think we did some math that said if you take the amount of lead in a lead acid battery for an old car, and then you take the amount of tandem panels that we can use, or perovskite panels, it would fit up 5 football pitches. So it's a really, really, really small amount of lead. It's a nothing burger, as some people would say, a non-issue.
And is that just because it's in the perovskite itself, and the perovskite is 1 micron thick, so you can probably just eat it?
It's a really, really small amount.
And we did the same math, Scott. It's kind of funny because we looked at, if you took like the automotive industry's 1 year production, just 1 year, lead acid batteries, even EVs use lead acid batteries for all the 12-volt loads, right? So your instrumentation cluster is not on your lithium ion batteries. It's on your 12-volt lead acid battery. You can go back into the fourth to the moon 9 times if you were to have an equivalent amount of perovskite solar modules. So it is such a tiny amount compared to what is produced in the automotive industry and what even we use in the technology.
Yeah, I'll throw in another that my team that some people I told a bit confused about, but I like. If you took our panels and you put them into the ground and you just measured against soil, we have twice the amount of lead that naturally occurs in soil. So not very much.
That's fun. Yeah, our guys did the same calculation. It doesn't even hit background. It's really small.
So with any luck, the regulators should actually take that on board instead of being sentimental.
We should just take it as it's a huge improvement what we're doing on the lead side, and I believe we have approaches on recycling, and others do as well. So not an issue. It's more like scare tactics than anything else, but we're better.
So the next 2 questions
that's the other thing, is it can be recycled.
You
can recover it, especially for us, especially on a flexible substrate. You just rinse it out.
So actually, does this mean that tin is not really relevant? You might adopt it if it's easy, but
no,
all of these
perovskite tandems, it's a very appropriate, right? Because you're trying to get different band gaps, and so a tin perovskite will deliver a different band gap than what a lead halide perovskite will deliver. So it could be part of a perovskite tandem in the future.
Especially, there's so many potential. I think First Solar was looking into some kind of cadmium perovskite tandem, which would be a whole different band gap from what's normally done.
CZTS.
But then again, they also spoke about a cadmium telluride plus silicon tandem, and that seems to have gone nowhere. So I better start rushing through these questions just to make sure we get through them all. And if we rush through them quick enough, we can go back to a more dilatory style of conversation. But the next 2 from David Martineau again are, he's asking about reverse bias degradation and potential induced degradation. Now, is that a problem for perovskite specifically?
You might have the wrong guys on the call for that. But no, I think our teams have done a lot of work when it comes to hysteresis and reverse bias degradation modes. And, our customers have been satisfied with the results, is what I can say.
Okay. He's got a question which is just encapsulation for acceptable longevity ? And he says EVA not compatible.
Correct.
It's just a question of keeping the oxygen out, right? And the water.
See, and for us as well, if by focusing on an indoor low light applications, our those problems are a lot less because we don't have to stick it in the sun and the hail and the hurricanes and whatever else.
You don't have to go to space to escape all of that then.
No.
And
so for us, we can address those issues a bit more slowly while we build into full sun products.
We've got a couple of more technical ones from David Martineau. So maybe I could even talk to your teams about this if they're too technical. So one is metallization over perovskite top cell ? E.g. corrosion. Ring any bells?
Yeah. Not something we need to solve for in a semi-transparent device, and even an opaque device. There's methodologies to avoid that.
Okay. And he's got another question. Slow response time. Flash QC and MPPT. Okay. This is his last one.
I'm going to guess he's talking about light soaking, which is a pretty typical phenomenon for thin film devices. So, yeah, probably better if he talks to our squad about that.
Okay, well, I've got one for you, Mr. Fontaine, from Matthew Welper. And he's asking, how does Halo Cell's roll-to-roll process compare to the one from Energy Materials Corp? If you know. Well,
they haven't been banging down our door telling us what they're up to, and what's on their what's available publicly is a bit lean, but the same is true, can be true for us. So I guess I can't really. I'd like to talk to them, and I think I've reached out to them a couple times trying to because, like I say, if we can start producing these in volume, there'll be applications people hadn't even thought of yet. It'll become a people go, oh, hang on, we can use if we can produce power indoors, we can use it for this. I mean, I'm dying to get one on my Kindle because you have to charge those up all the time. They've got a big surface area. So I'd like to talk to them. And
we actually have a question from Dave Dwayme, and he actually is the Energy Materials Corporation guy. So hello, Mr. Dwayme, if that's the same one. And he's asking, what is the selling price expectation for a silicon perovskite tandem at launch and in the future? So cents per watt, I suppose.
Silicon
perovskite, yeah.
Okay, that rules us out.
So the way that we think about it is a bit differently. So we try to intersect a price point that we can keep the cost per watt relatively close to what the customer started with. And that's the same calculation we talked about previously, and how do you calculate the power. So when we look at the US, our selling price is between 10 to 12 cents per watt, depending upon the customer, frankly. And when we're selling into Asia, it's between 7 to 9 cents per watt to start. And so that should achieve in the US roughly parity with what the current cost per watt is. And I see Scott furiously taking notes, so he's got some great market intel coming.
That's good.
And
but in Asia, we'll have a slight premium to what the module price is, considering the super low cost silicon that's out there, right? So, but the one thing that we should highlight, and this has stayed true for quite some time now, is that for about 1%, and it used to be bigger when balance of system cost was higher, but for every 1% of absolute efficiency improvement, it's about 2 cents per watt premium that a module producer can command in the market. And we see that same behavior happening even in this low cost environment. Our team came back with some market data to show that, look, sales prices are dropping to 10.7 to 11.4 cents, and we see about a penny and a half to 2 penny premium for TopCon, and that reflects that efficiency improvement. So what we're talking about delivering to customers is a 6% absolute efficiency boost, which should translate to about 12% premium that they can command in the market. And so that's a pretty broad spectrum to where we can go carve out a slice for ourselves. And likewise, our module companies, our customers can go and have that conversation with whichever project developer they want and who's going to take what piece of that. So we really don't get too involved in the downstream pricing. So, but we try to price it such that the barrier to entry is small, but we also make a healthy profit.
And Mr. Bowie also asks a sort of question. It's almost more of an assertion. And he says, silicon production is dominated and controlled by China, 98% in the wafer segment, that's my insertion, and will continue to be, which is mostly true as well. So how does silicon perovskite compete with China when they control all silicon ingot and wafering? And I actually want to have a stab at this myself. The first part is the Chinese don't seem to be doing that much from perovskites yet, or at least they have a couple of companies, but it seems like the Western perovskite companies are bigger. And the other thing is that there is some wafer coming out of non-China. And there's Southeast Asia, there's India potentially. And even if you do have to buy some from China, at least you can make it go further, make it contribute to more kilowatts if you're also doing perovskites. I mean, but it is kind of it's a point of, Mr. Fontaine can feel smug about that question, I think. But I better keep running on because we've still got some more questions. So we've got a question from Alessio Palla, and this question is, when do you think tandem silicon perovskite modules will be available in the market with silicon-like warranty terms? And do you think Chinese companies will be the first movers? Now, I'm going to guess that they won't be. I sort of just said that, although they have some potential to be. I'm going to change the question. When will you be on the market with silicon-like warranty terms, or will the warranty be different because you can have more power up front? You don't really need to last quite as long, especially in a 4-terminal arrangement.
You'll see it next year.
Okay, very soon then.
Yeah.
So our target is when we launch a product that we'll be able to be competitive on warranties.
Exactly. Now that's table stakes, right? So yeah, we're talking. Customers are in qualification process now. We'll see the first products in the first half of next year.
There's some interesting math too. If silicon performance is actually much better than 80%, like some of them are saying, get to 90, 92, and you have a tandem and you can do a blend, the perovskite doesn't actually need to be as good in order to achieve the warranty. Now, I think we're all aspiring to get there, and I think we want to get there too, and maybe be better. But if you look at the math of the blend, you actually can get to T80 being below T80 because the silicon, in theory, we're taking advantage of all the reliability that they have. If they're at 92, then you do the math, say perovskites can be in the 70s, and then you get to your T80.
I'm just going to rush through a couple of the last questions. So we've got one from Skylar Bagden, and he asked, why won't China dominate perovskites? And my answer to that is they very possibly will, but for starters, a lot of that might get absorbed in their own market. And like I said earlier, there's so much difference in energy consumption that a lot of their advantage in silicon comes from the energy consumption. So that part of their advantage is no longer so relevant at all. I think.
And if every tandem has silicon wafers underneath it, they don't need to dominate. They're already in the product. Do they?
Well, and one of the things that we haven't touched on is that this is a great way for companies that are still in the mono PERC technology node. There's a lot of them out there, P-type PERC, to really boost efficiency and compete head-to-head with the premium silicon offerings out there. So you're talking about life extension for a lot of these companies, that if you can marry it with a perovskite top cell, they've got a 25% product pretty easily.
I'm going to end it in a few minutes now, just as we come up to the 1 hour mark. So one question that's probably quite simple. Napoli Gomez Laconish, I hope I said that right. They're asking, what turnkey manufacturing line is easier to convert to perovskite tandem? I mean, he's saying heterojunction, TOPCon, or XPC? And maybe that's more of a 2-terminal question.
It's a TT question.
Yeah, okay. So that brings us on to perhaps the last question I'll ask, which is, what are your thoughts on 4-terminal versus 2-terminal? That's from Daniel Prager, but also me. So is 4-terminal just perhaps not as powerful in theory, but easier to do? So therefore, that's the one that you should go with.
Scott, do you want to start?
I think I get back to what I said earlier. What problems do you want to solve? And my understanding with 2-terminal, you're solving way too many hard problems, which is why some of the players have struggled there. And the advantages of 4-terminal are many, but one of them is you take the most durable and reliable part of perovskite and you marry it with something that is absolutely reliable and works. So from a purist point of view, is it the pure technology? No. Is it something that works and is going to be the most reliable and stable and something the best to get out to market? I believe so. And I think it also allows us to leverage, probably as an interim step, where we leverage all the silicon that's out there today. And as the costs come down, our solutions comes down. And ultimately, I think, as you said, we're going to replace it. But why do it in the foreseeable future when it works? And also, I think Scott brought up some interesting business model choices. We have the ability to provide a perovskite solution to people out there providing silicon and give them a boost, make them competitive. And I think it's a really interesting choice for them to extend out the life for both of those offerings.
And just to bounce off of that, to Scott's point, we don't want to do substrate engineering. That's hard. That's hard to do that in addition to doing perovskites. But the other fact is current matching is hard. You can be voltage match connected in parallel and have a product that these cells operate independently. So you can take advantage of the fact that perovskites are better at blue shifted light. You start broadening the shoulders of that absorption curve over time, over a diurnal cycle. And so why do you want to short circuit that by messing with this current matching challenge that is really not trivial, right? We started off as a 2T play, and early on we went, this is not going to cut it. So really, this is the path to success.
Now, the CTO of Oxford PV, Chris Case, would definitely have something to say in response to all of that if he were here, but he isn't. And in a couple of years, I think we will have seen who's right.
I think everybody here knows where Chris stands.
So we've reached the 1 hour mark. I'd like to thank you all for your time. And we've got a contacts page, haven't we? So we've got anyone who wants to have further detail about the perovskite report, both the one from last year and the upcoming update this year, please contact Ros Hilton. I think here's our email contact details. And I'd like to thank all three of you. You're all in California, so this was all the California time zone. So this was pretty early in the morning for you. Thanks for getting up at the crack of dawn. And if you are annoyed that I passed over your questions, then please email me and I'll do my best to address it to those who I did pass over. So thank you and have a nice day.
Yeah, thanks for the opportunity. Appreciate it.